Okay, all, welcome to this seminar and thank you Beyond 2020 for this opportunity to share experiences on the important topic on climate improvement and on how carbon-free structures can contribute to this. I am Karin Hammarskjöld. I'm an architect and urbanist and working at Link Arkitektur here in Stockholm, and I will moderate this session. And the seminar's title is Carbon-Free Construction, a Dream or Reality? And we are fortunate to have three speakers who have both the knowledge and the actual experience on how this can be made into reality. But more importantly, I think there are three visionary dreamers who have yet higher goals on how to increase carbon-free construction in the world. So let's listen to how that can be done. So I will introduce our speakers in order of appearance, but I suggest that we're saving the questions from you. We are gladly taking your questions, but we're saving them to respond collectively in the end of these three mini lectures. Our first speaker is Alexander Landborn. He's a sustainability manager at Link Arkitektur. They focus on climate smart building. And he's a trained engineer in environmental engineering and has specialization in renewable systems and sustainable cities. And among other projects at Link Arkitektur, he has experience of Sweden's first Noll CO2, that is a carbon-free certified building. And he will, in his talk today, describe the main lessons from designing that. And amongst other things, he's a very cheerful person with a very positive outlook on life. And I'm very happy to introduce my colleague, Alexander Landborn. Please take it away, Alexander.
Thank you, Karin. Thank you very much. I'm going to share my screen here then. I just want to say that I love the title of this seminar, Carbon-Free Construction, a Dream or Reality. For me, because it implies that the reality part is the good thing, that it's around the corner. The carbon-free construction is around the corner, and or that it's possible today. And that somehow the dream, that if it only was a dream, then it would be a bad thing. But I think that this is a misconception, because the dream is actually a really, really important part of this process as well. If you look at the people who's changed the world, it's their ideas, their vision, and their dreams that actually change the world. One of my favorite idols and entrepreneurs once said that, he said a beautiful thing. He said that if you wake up in the morning and you believe that the future will be a better place, then it's a bright day. Otherwise, it's not. And I think that rings so true. And it also reminds me of this old proverb, where if you want to build a ship, don't gather all the men and women and send them out into the forest to chop down wood, but rather make them yearn and make them dream about the vast and the endless ocean. I think this is so true, that we need to have a dream if we want to build a fossil-free building sector. We need to have a dream and vision to strive towards. And that's one of the reasons for why we have at Link Arkitektur have focused a lot on timber buildings the last couple of years, because we believe that timber is a renewable material that is a very important part of the building sector of the future. This is one of my favorite projects, which is called Hoppet, which Elsa will talk more about later on. And I think it's so fun because it's an experimental project where they try different types of materials with low carbon emissions. And it's also an inspiration for the rest of the project developers in Sweden. Everybody got their eyes on this project because they want to see what's working and what's not working. This is another project that I like that we have done at Link Arkitektur, which is called, it's a little store outside Sigtuna. And it's mainly built out of glulam timber and also cross-laminated timber. And I think it reminds us also that architecture needs to be beautiful. If you want to have a building that lasts for 100 years or centuries, the architecture needs to attract people for us to love it, to let it stay there. And this is one of the pictures being built right now as we speak. So where do we begin? Well, if we want to build climate smart or a carbon-free construction, we need to focus on the building material. Many people believe that this graph illustrates now the carbon emissions from a building over a lifespan of 50 years. And as you can see, the building material stands for a large majority of the climate impact of the building, even larger, often larger than the energy use during these 50 years. And this is something, and the energy use is something we've been focusing a lot on the last couple of decades, and we've been able to reduce this circle a lot. So what we now need to do is we need to focus on the building materials, because the fact is that we don't know much about how to reduce the climate impact from this part of the building, because there's very little research done on it. So how do we begin doing that? Well, I think a great way is to use the Paretos principle. It states that for 20% of the effort, you get 80% of the results. So I usually don't encourage people to start with everything at once. If you want to build a climate smart building, don't start with all of the building components. Now I can see that I actually have put the text in Swedish here. But what it says here is that this is the foundation and this is the framework of the building. And this is like the technical parts of the building and other parts. So what we can see here is that the framework and the foundation stands for a large majority of the climate impact, even though it's only a small part of the building. It's the same with sales. Usually 20% of your customers stands for 80% of your income. So this principle can be applied in many things, and it's also true for the climate impact of a building. So you need to focus on the foundation and framework first. Don't ignore these parts, of course not. But if you're just getting started, then you put your energy where you get the most results, where you get most bang for your buck. And that's exactly what we did for this project. This is Little Visby outside of Gotland, which is Sweden's first null CO2 certified building. It's almost completely made out of timber. We're using cross-laminated timber, glue lam, and we're also using LVL. But there's two things that's unique with the project. And the first thing is that almost all of the materials that's inside this building has been accounted for and measured their carbon emissions from a product-specific EPD. So we know exactly how much carbon emissions they release. And the second part, which is really interesting, is that we used a carbon budget for this project, the CO2 budget, and of 300 kilos of CO2 per square meters. And the same way you use a financial budget or you have a time budget in your project, every project should also have a CO2 budget. So how do we get the target of 300 kilos CO2 per square meters? Well, in this case, it's taken from a baseline case where a standard building in Sweden has a climate impact of 550 kilos of CO2 per square meters. And then the thought process here is that you almost half that and you get 300, and that's then in accordance with the 1.5 degrees goal from IPCC. And actually these numbers have been updated since we worked with this project, but this is what we used. And of course, always when you have a target, you want to have a safety margin, right? So what we did was that we said, okay, we want 20% safety margin so that we know that we can reach this target or below this target actually. And we far outreached the target. The building had a climate impact of 180 kilos of CO2 per square meters almost, which is a very low climate impact for a building. And that is not possible with the way we design today. This is an illustration of how the design process looks today. You have the sketch, you have the volume, you choose which materials you want to use in the building, and then you go into more details. And when the building is complete, that's when you do an LCA analysis. I mean, there's no room for improvement when you do it here. When the building is complete, there is no room for improvement at all. And actually, another thing is that the learning process is very low, because the ones that actually can impact the climate emissions are the architect and the construction engineers and the other consultants, and they're not part of this feedback loop. So that's why when you use a CO2 budget, you're forced to do these like continuous LCA analysis during the project. And you have to ask yourself a question when you start a project: are we able to reach this CO2 goal that we have? If not, well, what changes can we do to our sketch? And that's exactly what we did. You can see here that this is one illustration from an early stage of the project, and we're trying different layouts, and we want the same function to be fulfilled within these different layouts. And as you can see here, we have optimized the form and function of the building. We reduced the amount of facade that's needed. We've reduced the volume that's needed, and this is good for many reasons. I mean, there's less facade to be bought, so lower cost. Less materials means lower CO2. Less volume means that we don't need to heat the building as much or cool it for that matter. So it's a win-win situation. Other types of analysis that you can do early on is, for instance, looking at the framework. Here we have a glue lamp beams to the left and glue lamp trusses to the right. And this simple analysis shows us that we can save 100 cubic meters of timber early on without even doing anything. I mean, this can be a potentially huge cost saver for the owner of this project, which is, I think these types of analysis are amazing if you can do them, because many people believe that climate smart always means more expensive, but actually climate smart and cost efficient are intertwined. I mean, if you reduce the materials, the cost will also be reduced, hopefully. Not always, but in many cases. So that's why they're intertwined. And I think that's important to remember. This is what a regular type of LCA analysis looks like in many projects. It's very simplified. You have a concrete wall to the left and you compare it to a timber wall to the right. But this, you can't do this because there's always materials that needs to be added to the different types of constructions, right? So in this case, this is more of an accurate analysis where you can see that you need to have a lot of gypsum for the timber wall to protect it from fire. You need to protect it from moisture, the acoustics, you know, so there's a lot of materials that needs to be added to the wall. Now, this is a more reasonable comparison to look at these walls. And this is perhaps something that we do more often, but I would like us to take the next step and take this wall and understand that this wall is part of a system. And that system is, of course, the house or the building. And this wall will impact the whole system. So let me give you an example. In this case, we have a concrete building to the left and you have a timber building to the right. Now, the concrete weighs approximately 5 times more than timber. And that means that the building, of course, is much heavier, which impacts the foundation of the building. This is nothing that we saw when we used to compare the walls together. But so there's a synergy effect of using the timber wall that we can have less foundation. Now, this is an oversimplification and it's not always true, but in many cases it is. And using less concrete and steel in the foundation also means less costs for the project developer and also less CO2 again. So this is a breathing pause for everybody. Actually, it's not. It's used to symbolize that timber breathes CO2, unlike us. And this is a great way of potential that we can, that we should try and tap. And if we look at the graph we saw earlier for the CO2 that's stored within the timber, then we could argue that the building actually has a negative climate impact. And this is a concept that I think that we definitely should explore further on, because that means that our buildings could become part of the solution and not be part of the problem in the climate change debate. I mean, which sector has that possibility to be part of the solution instead of part of the problem? Our buildings could be carbon sinks. And I think that's a fantastic opportunity that we should explore further on. Other things that we can look at early on in the stage is, of course, the angle and optimization of the roof and orientation of the building to optimize it for photovoltaics or solar cells. In this case, by simply optimizing the roof, we get an increase of 60%. And the buildings might look like this. I don't know what is this. Is it a house or what is it? It's actually one of our projects in Norway. I think it's really cool. It's called SEB Flexible Labs. And it uses photovoltaics almost everywhere and has very low carbon emissions. And I think this is also something that we should take into account, that materials should be multifunctional and have more purposes, that they should not only protect from weather and wind, but also produce energy. I mean, that's amazing. If we look at this image, it shows the surface from the sun, and every hour the Earth is hit by 430 quintillion joules of energy per hour. That's more than the whole global population uses over a year. Let that sink in. Many people believe there's an energy problem, lack of energy. There's not. It's absolutely the other way around. And we should just start tapping out this energy as much as possible. And perhaps not build houses, but start looking at it as we're building power plants. And yet again, this building is producing more energy than what it is consuming. So perhaps you could see it as part of the solution and not part of the problem. And that's what I want to leave you with here today, that we need to change the concept of how we look at buildings. Don't look at them as problems, but look at them as part of the solutions. Which other concepts can you think of? But I think it's amazing to think that our buildings could be carbon sinks and also that they could be power plants. And I'm going to stop share here. And I just want to say one last thing, and that is that I understand that many of the things that I've shown you here, that they might not be trivial and not be easy, but that's not why we're doing it. We're doing it because it's hard and because we want this challenge. We're doing it because we want to build a better future. And I promise you that if you do this, even if you live in Scandinavia and it's November and you wake up and you're trying to achieve a better future, your day will be bright. Thank you.
Thank you, Alexander, for this very professional yet very personal message to all of us. I want to encourage you all to write your questions in the chat. And if we have any latecomers to the seminar, this is a seminar called...
No easy questions.
Both easy and hard. Sometimes they're both at the same time. If you have any newcomers to the seminar, it's called Carbon-Free Construction, Dream or Reality. And on this topic, we have our next speaker, who is Tove Lindblad. She is a business development manager at Trimble Solutions in Sweden, and she has a very broad role that includes overall goals for how, where, and whom Trimble conveys Trimble BIM and the use of open format, constructible models, seamless workflows, sustainability, and so on. She is also part of several global teams and participates in industry meetings and has the main responsibility for operations in universities. And on a personal note, she likes to share time with her family in the nature. And that is Tove. I leave the screen to you, Tove, and your presentation, please.
Unmute myself. Thank you, Karin. I will share my screen. Here we go. Can you see it? Let's see, I will do it this way. Well, yes. Okay. My name is Tove Lindblad and I work for Trimble.
I don't think you could see the presentation yet. Could you test to share again?
Here we go.
Can you see it?
Yes.
Yes. Good.
Thank you.
Welcome. Sorry, something happened. Yes, thank you, Karin. And I work for Trimble Solutions Sweden. That's part of Trimble Corporation. And we are located globally all over the world. And we work with, we provide software for constructible models. We work with open formats such as IFC. We work with sustainability, of course, and animation. And we do that through the building of a life cycle. I will talk about Trimble connected construction that provides along the project life cycle with confidence by improving productivity, quality, transparency, safety, and sustainability. And that's why I'm here today. I will share how LCA analysis in early stages can be used as a guideline through the design process. We transform construction projects. The industry's digital information is the construction process. The picture you see here says constructible, connected, and content enable. That's regarding the constructible process. The 3 C's for us is very important because the constructability, those models, they will do a sustainability perspective. To achieve carbon saving potential, you need to do carbon reduction in early stage, just like Alexander mentioned, in the building process. You need to do that during the conceptual design. And when you use Tekla Structures Designer, you optimize the structure instead of just optimizing one project, and you will have your frame solution. This image serves as a visual image of how we see the life cycle of a building. And of course, we do have similar pictures for infrastructure. The process begins first with a plan, and here starts your opportunity to think and to work with the sustainability. Early design optimization have the highest impact on carbon saving potentials and to the lowest cost. Architects and designers can reduce projects embodied carbon by 80% in early stage normally. However, you need accurate material quantities to have a sound carbon reduction strategy. And that's normally, it's challenging in the early stage. And like I said, and also Alexander, it is in the early design stage, during the conceptual design that you have, and you can make the highest impact on the carbon saving potential. The integration between Tekla Structure Designer and one-click LCA helps you to get those materials quantities much faster and more accurately. With this integration, you can actually export material quantities from Tekla's early stage models to one-click LCA and get a life cycle assessment in minutes. You can then compare the embodied carbon of different early designs and find out the most eco-efficient solution. We have together with one-click LCA a mutual understanding between us, and this is a stepstone on a longer journey together. You will get a complete picture of the whole life carbon and other impact indicators. With the modeling Tekla Structures Designer, you have the measurements of a building quantities, and you do have the profiles, and then you push the data directly in to one-click LCA for different LCA options. No manual steps is needed, and that makes it very beneficial. I would say that LCA answers one simple question. How sustainable is my building? Or why not product or process? We know products are not equal in terms of their environmental impact, and putting a number on to that can be hard. LCA is standardized. It's science-based tool and is quantifying the impact, answering the simple question, how does my building affect the environment? This picture shows how you can get reliable evaluations of an entire building life cycle immediately. On the upper line, you see the Tekla Structure Designer. You see the 3 stages. You see the concept design, you see the design development, and you see the design completion. And with automate LCA, with BIM integrations like this, you can get results to comply with ISO standards, LEED, BREEAM, and other certifications. You can see those impacts of a building very fast. We do, as you can see here, you can focus on the hotspots in the building structure. Alexander mentioned regarding the product stage, the floor, the foundation, and so on. It's the heavy post. And as you can see in the diagram, you have the light blue is for product stage, it's raw material, transport, and manufacturing. You have the second phase, the darker blue, it's construction, it's transportation and installation process on site. You have the user stage where you use maintenance, repair, replacement, refurbishment, overall energy and water use. And then you have the end of life, the deconstruction, the transport, waste, and the processing. And the graph just states % of the embodied carbon coming from the whole life cycle stages of the building. The eco design would decrease the total embodied carbon, but would not necessarily change the percentage, because this is how it looks like. As well, we have the climate declarations, and to optimize material, you use the LCA, and you optimize for different frame options, material options, supplier options. You do manufacturer options, and as well minimize the emissions. You can also reduce waste with the constructible BIM models, and you are the key to change if you take that step. So, a constructible model provides sustainability. What are the changes that are required? How can we work today? We built for 100 years at least, and that's something we need to have in mind. Can we assume that the function in the building will be the same? Will there be reconstruction? Will there be some other building management? So the decisions made during the journey need to be considered. And with Tekla, you have that. You have the constructible model. It's so accurate, you actually can build from it. You can use the model to reduce the consumption of raw materials. The wastage is reduced or actually eliminated completely. You can use the model. You can build with a limited number of drawings, or why no drawings at all. You use real-time product views instead. That's also sustainability. So there is no reason not to use the constructible model to work with sustainability thinking. And for the property owner as well, it's very important to know what's inside of the building, not just the exterior cosmetics. You need to know exactly the richness in details, so you know what the building, the whole thing are included. The building is what's inside, of course. We talk on EPDs, which you can produce easily with models, and it's complete because it's a high lot of 500. So a model-based workflow can give you a whole lot of benefits throughout the life cycle. And the use of the constructible models, from concept design to highly detailed models used in production, and they are used further along. A life cycle that benefits us all towards climate declarations, climate neutral buildings and civil constructions. Use the one-click LCA calculation and work sustainable. Thank you. Yes.
Din mic, Karin.
Sorry, can you hear me now? I'm sorry, I didn't unmute myself. Thank you, Tove. Thank you very much. It's very inspiring. And as with Alex speak, we are hoping that you are saving your, actually writing down your questions to Tove in the chat, so we can take them collectively after our last speaker, who is Elsa Fahlén. And she is an innovation leader for the transition of fossil-free and climate-neutral construction at the local premise administration in the city of Gothenburg. And she has a PhD in sustainable energy systems and has several years of experience from research and development and innovation in the construction sector. She spends her free time writing songs and playing guitar, but that's not what she's going to do now. She's going to tell us about her very practical experience on carbon-free construction. So please, Elsa, will you share your screen? Yes, and here she is, Elsa. Take it away. Thank you.
Thank you very much. So as Karin mentioned, I work at the local premises administration in the city of Gothenburg. And we are one of Sweden's largest managers of public premises. And every day we have about 150,000 visitors in our preschools, schools, and other public buildings. And we're the owner of about 400 preschools. And the city of Gothenburg has really high ambitious visions and climate targets. For instance, the politicians decided in 2017 that we will build a preschool that is as fossil-free as possible. And this will include raw extraction of materials, transports, manufacturing, and also the building site and the operation of the finished building. There is also a decision that the local premises administration will be fossil-free and climate neutral to 2030. And today, no or few products can be considered fossil-free and climate neutral if we consider the whole life cycle perspective, and if biogenic carbon is not accounted for, I should mention. And by 2030, all our new buildings should be fossil-free and climate neutral. So this is a really short time period for such a big transition to fossil-free construction. And small stepwise improvements are good, but not enough. So there's need for innovation in products and materials, and there's also need for innovation in the processes that we use. We call this innovation project for HOPET, for fossil-free and climate neutral construction. And HOPET is a word with double meaning. The name symbolizes the hope for the future, a leap for the giant step we want to take in this project, and also a jump, as in this wonderful picture from the first SOD event. And HOPET is not only a construction project, it also includes several research and development projects. It includes test beds for new technologies and materials, and it also includes communication and many kinds of collaborations. And now I will show you some of the solutions in the first HOPET pilot project. So this is the preschool visualized in this picture. And I will start with the foundation and framework. As Alexander and Tove talked about, the foundation and framework correspond to the major part of the embodied greenhouse gas emissions for a building. And instead of using a concrete slab, we have used building elements based on a steel frame and cellular glass insulation. And this insulation comes from up to 70% recycled glass. And actually this week, these elements are lifted in place and assembled. And we also have chosen a framework mainly based on wood. This is the resulting climate impact for the main building parts of HOPET, for the foundation, framework, and roof construction. And for the main building parts, we see that we can have a 70% climate impact reduction compared to a reference preschool, representing how we normally build. If you want to look deeper into the calculations, we presented a paper this Monday, and I think the paper can be found at the Beyond 2020 website. One of our strategies to build fossil-free is to reuse products and to use products made of recycled materials. For instance, we use plastic pipes made of installation waste. Another example is that we want to reuse construction elements as foundation for the complementary buildings at the site. And for instance, we want to reuse hollow core slabs. Now we have come to the most innovative parts in this project. We realized that we need more options when it comes to building materials. Wood is a big contribution that we can reduce the climate impact so much for the major building parts. But wood is needed for many different applications, and there is not wood enough for all buildings. There are 3 complementary buildings at the site that we will use as test beds for materials that are not very well established in the Swedish construction industry today. And we need smaller tests and validation before upscaling these technologies to full-scale projects. We will build one of the buildings with hempcrete combined with bearing elements of wood. Hemp grows fast, also in Swedish conditions, so there is potential for local production. And hempcrete is a material with many interesting properties, for instance, when it comes to acoustic and thermal properties, and it also buffers moisture. In one of the buildings, we want to use building bricks made of as much as 90% demolition and construction waste. Today, these are manufactured in Scotland, but there are ongoing discussions to start manufacturing also in Sweden using Swedish waste. And regarding technical properties, these bricks are similar to normal clay bricks, but they only have 10% of the climate impact in comparison. And clay is one of the world's most common building material. And in Gothenburg, we have a lot of clay. And we have many infrastructure projects ongoing. If you were here, you would have seen it. And we have a lot of clay that we have to get rid of. And if we use the clay as a building material, we can build many buildings. And today we collaborate with Chalmers and a small company to make a prototype for a rammed earth wall. It's a solid wall. And we will also use clay boards and plaster in this building. And common for all of these 3 materials is that they are unfired and no cement is used. To sum up a little bit, we have taken a giant step ahead with the first half of preschool, but we didn't quite reach the goal. But even if we found that it's not possible to build 100% fossil-free and climate-neutral yet, we have found that it's possible to reduce greenhouse gas emissions for major building parts by as much as 70%. And with this project, we think that municipalities can show the way. And for now, we conclude that there are solutions available today with considerably reduced climate impact that can be implemented directly. Another low-hanging fruit is to reuse products and recycle materials even more. And we have to develop the processes for this so it becomes easier and cheaper to reuse instead of buying new products. And finally, we also need more research, more innovation and cooperation to become 100% fossil-free. And therefore, the innovation project Hoppet will continue. So if you're interested, you can read more on our website. Thank you very much.
Thank you, Elsa. Thank you very much, and thank you all. I can see that we have several questions, both large scale, almost on the ideological perspective.
Trump or Biden?
Well, and the very specific. So I'll just try to find a mix here of really curious questions. I wish we had more time. But I'll start with you, Alex.
Yeah.
According to the IPCC, we only have 7 years left to meet the
1.5 degree target.
Yes. Are we too late? Why are you so pessimistic or optimistic? Sorry.
No, I'm not sure that we're too late, but I think that, you know, it's always, we usually think, like we humans, we think in a linear way, right? So we think that, well, it's only 7 years away, and yeah, that's not so much time actually, and you might be daunted by thinking it's only 7 years, but I think you need to think, realize that the solution to this is you have to think exponentially. So if we can make our buildings as carbon sinks and as powerhouses, then yeah, sure. We're not talking about incremental change like 10% each year, then we're talking 10x change. And if you talk 10x, then I don't think it's too late with 7 years away. But sure, if you look globally, it might be a very daunting task to take everything on you at once. But I think you need to focus on what you can do and do the best what you can do with what you're working with.
Yeah. Yeah. Is anybody, Tove or Elsa, do you want to comment that?
Are you pessimists or optimists?
Optimists.
Fundamental question. Yes.
Yeah, I think we need this hope, but we also need the actions, as Greta Thunberg would remind us about.
Yes,
yeah.
Absolutely.
Tove, I have a more specific question for you.
Yes.
Maybe the technical. Why use Tekla models when you work with LCA analysis? What's the point? What does Tekla do?
What does Tekla do? I would say that, let me see, it's an advantage to use the Tekla models in those calculations because the models are exactly, I mean, we have everything in there because of in early stage, you really have the numbers, you send them for this example to one-click LCA and they can really do it. There's no manually printing down numbers and changing. So that's why. And if you go further on, you do have, you can reduce waste with the models because they are constructible, because you have everything in them, and it will result in like smaller garbage heaps, if I can say like that, because you will really optimize the material. So there is no waste. So simple answer, I would say.
Optimization, right?
Yes.
That comes up several times, optimization. I saw a question in the chat that relates to that. That has to do with, it's Carolina who's curious. She says, in regards to carbon, sorry, just have to bring out the full question here. In regards to carbon sinks, if the timber is not reused at the end of life, the carbon will be released again. So it's only stored for a certain amount of time. Was the building also planned for circular reuse? I mean, that's more directed to you in a way, Alex, from the...
Yeah, I guess also Elsa could answer that. But I think that, you know, there's two questions in there. One is like, if the timber is not reused, then the carbon is released. Well, actually, science shows us that even if we release the carbon, but we delay it 75 years, 100 years, 150 years, there's still a climate positive effect of that. Don't ask me exactly how that works. You have to talk to Martin Erlandsson at IVL. But there is science that says that. And the second part is that if you look back in Sweden 50 years ago, we encouraged people to drop their rubbish into the archipelago and drop it down to the bottom of the ocean. You're talking about a building that will be built today, and then perhaps it stands for 100 years. It's 2120. And do we believe that we will just take down this timber and burn it? I have very difficult seeing that, because it's a waste of energy and resources for everyone. So no, I don't think we will burn the timber. But I understand if people are skeptical about this, because nobody can guarantee it. But I don't think that's the way we will treat waste and resources in 100 years. The second part is that there was a question about the circularity. And no, we haven't designed it for circularity, but it's something that we're looking into a lot because we think it's important. But there's a benefit with timber buildings, and it's easier to recycle and reuse timber because usually you use screws in the joint, so you can just unscrew them and take away the timber and perhaps find another use for it. Also, because it's lightweight, it's easier to handle. So yeah, that's my answer. Elsa, do you think?
Elsa,
am I completely wrong here?
I agree with you that wood frames, it's easier to design them for deconstruction and for to be able to reuse later. And also, if you have prefabricated solutions, it's easier. And instead of burning the wood, it is also a possibility to make biocoal.
Yeah.
And if the building is completely thin, is end of life.
Yeah. I don't know how the biocoal works with, since it's glulam, you still have glue in it. I don't know how that affects making biocoal out of it, but I think that's a really interesting option also.
I have several questions on new materials. I'll pause them. And there was one thing that I think was very interesting that came from Stephanie, and she asked you, Elsa, or actually amazing to see the support of the city of Gothenburg in these amazing initiatives. How did you collaborate with local industry to identify the materials with the most potential?
I think we have scanned the market, not only in Sweden, also in other countries, to find these solutions. Because when it comes to hempcrete, it has been used since the 1990s in France. So they have more experience of that, and also clay is a very common building material in the world. But here in Sweden, we have also used it in Sweden, but it was a long time ago, at least when we talk about these unfired solutions. So I don't know why, but we have lost a lot of this knowledge about using clay as a building material. So yeah, we collaborate both with local suppliers, but also in other countries. As for example, with this, the building bricks made of the demolition waste. We had a living lab in Gothenburg where we invited different suppliers and producers to show their project. So there were both suppliers from Sweden and from other countries.
Okay, thank you. I have another interesting question from Hans Olof. How do you validate the performance of the building materials? Innovative materials don't have harmonized standards to validate from. Are these interesting circular refurbishment projects in Sweden? Didn't understand the last one, but Tove, do you think you can? How do you take in innovative materials in your models?
That's actually up to the designers to do, and of course they can do that. For us, we have the open platform, the open formats. They can actually create them themselves. So it's so fantastic to hear about Elsa's story regarding those bricks, because that's one thing in the chain, to reuse old materials, because that's what we need to do. We cannot just bring in new ones. Yes, it's possible. I would say they are already doing that.
Yes, I have another question for you, Tove. You mentioned the constructible models from a sustainability perspective. What do you actually mean by constructible models, and how can it help enhance sustainability?
I will go back to, you have less waste at the end, I would say. You have the constructible, the constructible model. If I use the Swedish word, it's byggbar. It means that you really are building the construction before you build it outside on the field. So for the how can I say? I mean, you really, because of the highly detailed models, you know exactly what's inside of the building. And that's very important from what Elsa just showed, that if you want to reuse materials or buildings, you need to know exactly the things inside of the building. And you need to know the location, for example, for the rebars or the electricians or whatever. So you can really take advantage, and you can really use the materials in the buildings to shape something new, instead of just put them to rest. So it's the circular way of working, and that's the important thing with the constructible models. That's what you can use them in the longer far end. of life of the building, for example.
Are you saying the model is more sustainable in itself?
In one way, yes. No, but you need to compare models to models, I would say, because it's starting to get very important. Our customers are asking, how can we create EPDs from the models? And you have those because you have everything modeled in the model. So of course you can use that information for something else in other tools, like from economics to the one-click LCA, or why not a tool who focused on what can I do with this thing later on. And as well, the architects and the designers needs to start thinking also, will this building be like this in the future? For the school now, Elsa showed, the preschool, what will happen when you don't have kids any longer in that neighborhood? It will probably, in my mind, be an older home. You change the usage of the building. So that's also something we need to adapt into the design.
I think it's an interesting question, about this, like innovative materials and how do you take into account, because many of these companies, they can't afford doing an EPD, or perhaps it's not their priority to do it. And so somehow you have to have like a balance there. I think that, okay, focus on EPDs because it needs to be quantifiable in the model and LCA, but sometimes you also need to take a leap of faith and trying things out to support people who are actually driven and engaged in the climate change debate, that they want to do something good and their product is based on principles that are common sense, like circular, reusing waste. These are things that we want to encourage, and we don't want to have too much bureaucracy to stop them. I think this is important.
That's interesting, and it sort of connects to the next question I have to Elsa. Which mindset would you say is important to have when breaking new grounds? You're an innovation leader.
Yes, I think, in this kind of project, there are always unexpected challenges. So I think it's really important to be committed and have patience and also perseverance. And when we started the design phase, we agreed on the mindset that we will have in the project. And we said that we must be brave and open for new ideas. We need innovation, so we need to be open to the new ideas.
Yeah.
And this can, of course, be challenging to use new materials and new processes. For instance, when we want to reuse products. But instead of saying this is not possible, try to see how it can be possible. And we also agreed on the attitude that we will do this together. And this includes to be transparent, to share your knowledge with each other, and also to be responsive, sensitive to each other's input. There are so many different aspects to take into consideration, and often we have to make trade-offs between different goals.
So yes, both a determined and flexible approach. Yeah. I also get the question from several people. What experience are you taking with you from the Hoppet preschool? And Johanna asked if you're planning to use the insights from this project to other preschools, or what are you bringing with you?
Yeah, thank you for this question. Now when we know it's possible to reduce the climate impact by as much as 70% for the major building parts, we need to start doing. And we have the opportunity to develop our technical requirements that are used for all our buildings. And we prepare to include a maximum level of greenhouse gas emissions, as Alexander said, a CO2 budget. But we're not there yet. But as a first step, we will require climate calculations, first in the design phase, and then when the building is finished. But in order to hurry up the wide implementation, we are also investigating if we can implement Hoppet solutions already in the projects that we have in the pipe.
Okay. Thank you.
But then, of course, we also use all the investigations made in the first project to start new innovation projects and pilot projects. So it's easier for us now than it was in the beginning of the first project.
Of course.
Now we know what we need to do.
Since we've been working with the Hoppet preschool, fossil-free preschool as well, I mean, I would like to comment on this as well, because one of the greatest takeaways that I have taken from that project is because you're invited to this group of people who are really engaged in trying to reduce the climate impact of buildings and producing these materials, and they've dedicated their whole life, started companies producing these new materials. And it's, I did not know probably 50 or 70% of these producers. I did not know about them before I was in this project. And it's amazing to see there's so many people who are actually doing something about it, and they're just trying to break through the standardization of the market today. So things are boiling.
Yes, we sort of have to conclude. I haven't been able to go through all the questions. I don't know if we'll ask administrators if there's any way of getting back to those questions we haven't been able to answer. But I have one last question to all of you, and because the three of you with your different expertise and perspectives have all been talking about the importance of optimization, of course, but also about doing this change together. And from your perspective, what do you think is the most important that you can contribute within this togetherness? Tove, I start with leaving the question to you.
I think the one thing, or if it bring one thing back from this session, I really want you to understand that it's the early stage. Just like Alexander showed really great in that picture, you need to start early because it's too late if the building is already there. So please do that.
Okay, and Tove? Sorry, Elsa, sorry.
Yeah, thank you. Yeah, I think more practical, I think partnering has been a good way, good type of project to work with this innovation project. And we have also met physically and worked in a project studio. So all the experts and consultants and also the preschool administration has been in the same room. And I think that was a key to find solutions. Find solutions we didn't know before we started.
Yeah.
Thank you, Elsa. And Alexander, what would you say?
I think that I would say that focus on trying to find people who are passionate about this subject and surround yourself with them. I'm talking about consultants. I'm talking about the producers of materials. I'm talking about your customers. Like, choose your customers who are engaged in this climate change or this fossil-free vision that you also have. Because if you surround yourself and you say, okay, I don't know everything, but people out there know much more than me, you try to surround yourself by them, you learn a lot, and also together you're much stronger. I don't believe in trying to convince all the people. Like, there's a small portion of people who are very conservative who don't believe that it's possible. I don't believe in trying to convince them. I believe in focusing on the positive people who in turn will become ambassadors, and together they will be able to convince the large or silent majority. So that's how I think we should work together.
Yes, and eventually they might just bring this exponential curve into something very positive.
Yeah, I mean,
change.
everybody has an iPhone, so it works.
Yes. Okay, thank you, Tove, Elsa, and Alexander, very much for your contribution in this, very important. And also thank you Beyond 2020 for our opportunity to join in this. And
thank you very much.
Not the least, thank you
so
to all our listeners. We can't see you, we know we're there. We are very supportive with all your questions. And we hope to see you again. Please don't hesitate to contact any of us, of course. I'm sure you find all the information in Brella to find us. So
yeah, thank you very much, everybody.
Flowers to the lot of you.
Thank you.
Thank you.
Ciao. Bye.
Bye now.
Bye.